Okay, so for chapter 10, all this chapter is about is taking those circuits from chapter 9 where we have the imaginary impedance things, and we're going to actually solve those circuits using all the stuff we learned before, node voltage, mesh current, and all that stuff here. So we're going to actually see this same circuit several different times. We're going to solve it by all of our different methods so you can kind of compare and contrast which ones are better and which ones are worse for you to have to deal with, for a given problem. So for this one, it says we want to use node analysis. And you'll notice they've already labeled the two nodes as V1 and V2. And it's important to know that you see there's a capital bold there. That's what we indicate when we have phasors. And in fact, this whole circuit has already been converted into phasors. That means that your sources are cosine of omega t plus theta, whatever that theta may be, but they don't actually tell you that. They don't write it in terms of cosine. They've already converted into phasor versions. And notice how they never gave us the omega anywhere in this problem, which means we are not going to know what omega is, and we're going to have to just write omega in our answer as something we don't know. Regardless, we can do this here. So if I look at the node 1 here, I would have V1 minus 0 over this 1 plus j down there in the first part. And then I have a current source going into it, so it'd be minus 2 angle 0. And then, oh wait, this is actually a supernode. So then I go, okay, so then the current going down over here would be V2 minus 0 over 1. And lastly, V2 minus 0 over 1 minus j equal to 0. So that's our first equation. We need a second one, but I will just do a little bit of simplification here first. 2 angle 0, if you do 2 cosine 0 and 2 sine 0, you're going to get just 2 there. And I will go ahead and multiply both sides by the common denominator, 1 plus j, 1 minus j. And by the way, when you multiply 1 plus j times 1 minus j, it's going to be 2. So then I would have 1 minus j times v1 minus 4 plus 2 v2 plus 1 plus j v2 equal to 0. And so at this point in time, we now can combine like terms, and I would have 1 minus j v1, and then it looks like a total of 3 plus j v2 equal to 4. So there's my first equation. Now I need my second equation. I do node voltage to this a second terminal. Oh wait, I can't because it was a supernode. So instead I would do the equation for the supernode that V2 is equal to V1 plus 6 angle 0. And again, 6 angle 0 is just 6. So V2 is V1 plus 6. We will go ahead and take that and plug it in to V2 there. And notice that in these problems, we do have 2 variables only, which is the most I'll ever give you with complex number system. And not only do we have 2 variables, but one you can plug in really easily. I'm going to try to make it so the algebra isn't too awful, but it's certainly not going to be super nice either, just because of the nature of the problem. V2 is V1 plus 6. And let's see here, I have 1 minus j v1. If I kind of go ahead and distribute the 3 plus j, and I have 3 plus j times v1. And then 6 times 3 plus j is 18 plus 6j. And then I combine like terms here. I'd have actually 1 minus j and 3 plus j is going to be just 4 v1. And I can move this over here. 4 minus 18 is negative 14 minus 6j. So v1 is going to be negative 14 minus 6j over 4. V2, which is what we need to find I0, is you're going to take V1 plus 6 So I'd have negative 14 minus 6j over 4 plus 6. That's 24. It's going to be 10 minus 6j over 4. And if I simplify that, my V2 then would be 5 over 2 minus 3 over 2j. And I'm going to go ahead and write that in polar notation here, because we're going to make our life a little bit easier here. So 5 over 2 minus 3 over 2i. And let my calculator do the work here to convert that into polar. And I get 2.92, let's say, angle negative 31.0 degrees. And then finally, we are asked for I0. So I find I0 phasor first, which is V2, in this case, coincidentally divided by 1, because that's what the impedance is there. And so we're going to have the same answer in this case. Now normally you would not have the exact same answer, but this is what we have here. And then I need I0 of t, because they didn't ask us for I0 phasor, they asked us for I0 of t. And so I0 of t then would be 2.92 cosine omega t minus 31.0 degrees. Maybe I'll write it a little nicer over here. I0 of t is 2.92 cosine omega t minus 31.0 degrees. This is amps. And one last reminder that we do not know what the omega is, so we had to just leave it as omega there. But if you didn't draw the omega, if you didn't write it down in the answer, it would be a incorrect answer. So anyways, okay, so that right there is how we solve this problem using node analysis. And as I said, we're going to continue solving it using all of our other methods.